Hello and welcome back to JD's Science Prep. Today we are going to be discussing naming straight chain alkanes. So, alkanes are organic compounds that are made up from single bonded carbon and hydrogen atoms. Functional groups will not be found on a straight chain alkane, and neither will alkyl groups or those branches. So we will get into functional groups and alkyl groups in future videos, but not in this one. So alkanes will always end with the suffix ane or ane, and the prefix used will depend on the number of saturated carbon atoms present. So we are going to fill out a table with the prefixes, and we're also going to take a look at the Lewis drawings of these alkanes as well. Okay, so just before we get into that, all of these straight chain alkanes will have some type of prefix and have the suffix of ane. Okay, so when these alkanes have one carbon or one saturated carbon, our prefix is going to be meth, and our Lewis drawing, we're going to have a carbon atom in the middle, and it is going to be saturated with hydrogen atoms around it. So remember, carbon will have 4 valence electrons. That's why it wants to make 4 bonds to fulfill that octet rule. So the formula for methane, we have 1 carbon, we have 4 hydrogen. It has to be CH4. Okay. And if we have 2 carbon, the prefix is going to be eth, ETH, and the Lewis structure will look like this. So we have 2 carbon in the middle here. I'm just going to move them over a tad. We do have more room. There we go. And it is going to also be saturated with hydrogen atoms. Okay, so notice both of those carbons, they still make 4 single bonds, but one of the bonds, this one in the middle here, is with that other carbon. Okay. All right. 3 carbon, we have the prefix of prop, and the Lewis drawing, you can probably start to see a little pattern here. We're going to have 3 carbon in the middle, and filling in the outside here, let's move this over again. There we go. And filling out the outside, we have hydrogen atoms as well. So again, all of the carbon are in the middle, and they all make 4 bonds. Okay, so that means their valence shell is full. The octet rule is fulfilled. We should fill out the formula for both ethane and propane as well. So we have 2 carbon for ethane, and we have 6 hydrogen. Okay, and for propane we have 3 carbon and we have 8 hydrogen. Okay, and just a little quick tip here. Just beside formula, I have CnH2n plus 2. So that's how we can figure out the amount of hydrogen in a alkane. So this N, this just represents the number of carbon, and it will also be inputted into our equation right there. So let's say for propane, we have 3 carbon. And according to our formula, I'm just going to write it out here again. If we have 3 carbon, that means it's going to be 2 multiplied by 3 plus 2, which will give us 8 hydrogen. Okay, and that makes sense. If I zoom in here a little bit, and we're going to look at propane here. Each of these carbon in the middle, I'll use a different color actually. Each of these carbon in the middle they are attached to 2 hydrogen each. So that's how we get the 2N. And this plus 2 comes from each hydrogen on the end. Okay, so that's how we get the number of hydrogen in each of these alkanes. Okay. All right, let's move on here. I'm just going to erase my lines really quick, and we will move on. All right. So next one we have is we have 4 carbon in the middle, and the prefix for 4 carbon is bute. Okay. And the Lewis structure is as follows. Again, you can probably guess, but we're going to have 4 carbon in the middle, and hydrogen are going to be filling in these spaces on the outsides. Okay. So it should look something like that. Each carbon is making 4 single bonds. It is saturated. The octet rule is fulfilled. So we have 4 carbon, so C4. And according to our little formula here of CnH2n plus 2, we should have 10 hydrogen. Okay, so 4 on either side makes 8. And these 2 on the outside add that plus 2. Okay, so that makes sense. Okay, and the next one we have 5 carbon. The prefix for 5 is going to be pent. And I already have the Lewis structure filled out here. We have 5 carbons in the middle, and we have 12 hydrogen filling in those outside slots. So we should have C5H12. Okay. Moving on to 6, we have the prefix of hex, and the Lewis structure is already drawn for us. So our formula will be C6H14. Moving on to 7, we have the prefix of hept, and our Lewis drawing is already created for us. We have C7H16. Moving on to 8 carbon, we have oct. That one's easy to remember. We have octopus, right? 8 arms, 8 carbon. And our Lewis drawing is created. We have C8H18. And we just have 2 more here, folks. The prefix for 9 is we have non, N-O-N. Lewis drawing is made for us there, and we have C9H20. And the last one, we have the prefix of dec, D-E-C, and the Lewis structure is created for us there. We have C10H22. So you'll notice when we get into the higher number of carbons, like from 7 to 10, it takes quite a while to draw these structures. So we're going to get into something called line structures here in the next video. So watch that if you need. And one more thing, we're just going to finish off naming all of these alkanes. So remember, it's going to go the prefix first, and we have to add the suffix of ane onto all of these. So 1 carbon, we'll have methane. 2 carbon, we have ethane. 3 is propane. 4 is butane. 5 is pentane. 6 will be hexane. 7 is heptane. 8 will be octane. 9 is nonane. And 10 is decane. And some of these you may be familiar with as types of fuels, and that's what most of these, if not all of them, are. So alkanes are usually classified as different types of fuels. Okay, if this video has helped you, please like and subscribe. Thank you very much.